hypothesis, making predictions, testing those predictions, repeating and revising any experiments if needed, reporting your results, and drawing conclusions. So we're going to go through a sample scenario, and you'll see how all of these steps are utilized. Okay, so our observation is, this is the scenario. You are a corn farmer. You observe that corn in the field with Miracle-Gro fertilizer grows taller than the corn in the field with no fertilizer. And this is just an observation that you're making as a corn farmer. So you could use this to develop your research or to develop your... Okay, so you base your research directly on the observation that you make, in this case, in a cornfield. We are going to use that observation, first of all, to develop our hypothesis, which is some sort of testable idea, which we'll then use experiments to see if that is true or not. Okay, so a hypothesis in general is a testable answer based on your observations. So our hypothesis, in this case, one example, is that corn grows taller in soil with Miracle-Gro. This would make sense based on the observation. We saw taller corn in the Miracle-Gro soil portion of the field as compared to the other portion that didn't have Miracle-Gro. Now remember, when you come up with a hypothesis, you also have to make a null hypothesis, which is the opposite of your hypothesis or a statement of no difference. And the purpose of the null hypothesis is to allow statistical testing. So in this case, our null hypothesis is just the opposite. Corn will not grow taller in the soil with Miracle-Gro. After your hypotheses, the next step is the predictions. Okay, your predictions are what you expect if your hypothesis is true. It usually is very similar to the hypothesis, except in a slightly different form, in an if-then statement. So my prediction is, if corn is growing in soil with Miracle-Gro, then it will be taller as compared to corn grown in regular soil. So notice that the prediction always has a form of if, then, whereas the hypothesis does not have that form. After you make your predictions, you need to test them. And usually this involves some sort of experiment. It might be a computer simulation, it might be a field experiment, it might be something that you conduct in the lab. And there's no right or wrong as to how you come up with the experiment, but there's definitely a couple different factors that you want to take into account. So again, we're going to be talking about this in regards to the corn and the Miracle-Gro. Okay, so the first question you're going to ask, are you going to do this in the nature, like in the cornfield, or might you want to conduct this in the lab? One of the benefits of doing it in the lab is that you can control a lot of the external factors, such as the amount of light, the amount of water, the amount of nutrients, the type of soil, so you can make it a more standardized scenario. And you're also going to want to make sure that you don't just have one single corn plant, right? That's not going to give you a good representation. You're going to want to have multiple, maybe 10 or 20 different corn plants that you're going to measure over a period of time. Okay, you need to be able to figure out what your independent variable is. Your independent variable is the variable that's manipulated. It's whatever is altered about the experiment. And you usually only have one independent variable. So for this example, our independent variable is going to be Miracle-Gro. Is there Miracle-Gro or is there not Miracle-Gro? That's what we're altering or changing in our experiment. And we also need to figure out what our dependent variable is. The dependent variable is what you measure. You don't change anything, but the results of the dependent variable depend on the manipulation that you've conducted on the independent variable. So in this case, our dependent variable is the height of the corn plant, right? That's what we're going to be measuring. We're going to either have Miracle-Gro or not Miracle-Gro. We're going to see how tall the corn gets over a period of time. So that would be our dependent variable, the height of the corn, which is dependent on if Miracle-Gro is there or not. Okay, the treatment is how we're manipulating the independent variable. So in this case, our treatment is the Miracle-Gro. And most of the time, the treatment and the independent variable are almost identical, if not identical. Okay, the other thing that you need to consider in an experiment is if you're going to have a control group or not. Now remember, the control group is used as a comparison to make sure that your results are significantly different from the norm. So the control group is held under normal standards, and the only thing that differs between the control group and the experimental group is that independent variable. We're definitely going to need a control group for this experiment, and the control group is going to be the corn that's grown in the normal soil. So we would have, maybe 20 corn plants that are grown in normal soil and 20 corn plants that are grown in soil with Miracle-Gro. And everything else is going to be the same. We're going to have a lot of controlled variables, such as the amount of light, the amount of water, the temperature, the amount of nutrients. We want to keep everything else constant except for the independent variable. Okay, and all of those consistencies are going to help us limit error, right? So we're going to have multiple plants, we're going to measure them multiple times, and we're going to keep everything else constant because we want to make sure that our results are accurate and they're not tainted by error. Okay, after you come up with your experiment, you're going to repeat it, and if it's not working, you're not going to keep doing it. You're going to reevaluate, and you're going to come up with a new procedure or a new experiment. So with our corn experiment, we want to make sure that we measure it at a specific interval throughout the course of the study. We don't just want to measure it at the end. That wouldn't give us the best data. So maybe we're going to measure it every week. Okay, and like I said, if your experiment doesn't work, revise it and try again. That's a big part of science. Step 6 is analyzing and reporting your results. Usually you can put your results in a table or in a graph. So I made this graph, and this is showing corn growth over 8 weeks. You can see the control is the blue line. That would be the normal soil. And then the fertilized corn is with the red line. So we can look at this and easily see that having Miracle-Gro in the soil did increase the height of the corn. Then you're going to use your results to draw conclusions. And when you draw conclusions, you go back to your hypothesis and you say, okay, was my hypothesis correct? Or did my experiment show me some different results that I wasn't expecting? Okay, so our conclusions